I'd like to introduce Mr. Jeremey Rentz from Tri-State University.
I'm glad he said Tri-State. Maybe I won't get in trouble now. Can you hear me? In the back? Yes? No? Somebody else have control over the volume? Excellent. We'll make sure everybody can hear me. I'm not very good with mics, so we need to get this worked out early on. Thank you for coming out on an interesting weather night in Angola. Streets are dry. It looks nice. We had a nice, beautiful day. And then I get up here, and it looks like you guys just had fresh snow, and I can barely make it down the drive. So 20 miles, and it's amazing what the weather will do for you. All right, can you hear me in the back now? A little better? Yeah, I don't want to feel like I'm eating this thing, but is that better? Excellent. All right. I'm on the back side of a sinus infection, so I apologize if at some point I need to take a sip or two, and then my brain stops working on occasion. So I'm going to do my best to remember absolutely everything, but that's why I have my slides here to help me out. If you don't catch something, or your wife interrupts you with a text, if you don't catch something, all of the slides are available. It's a Google Doc. Click the link, and you have access to everything. All of my sources for where I found all of the information are in the slides. Click on the pictures. You can find out more information if you like. All of the information that I have is fully available. You can share it with whoever you want, and hopefully you can find some of the videos that might be taken here tonight as well. We're going to get started with a little bit of a science lesson. I want to make sure that everybody understands one word, and that word is aquifer. When I say aquifer, I mean anything underground that holds water. In our case, it's sand and gravel. It could be limestone. It could be sandstone, granite. It could be a whole lot of things. Anything in the subsurface that holds water, and that's what we're going to try to focus on tonight. Very specifically, we are all here to talk about groundwater. And one of the very first things that I talk about in my classes with my environmental engineering students is that groundwater is not a big, giant underground lake. Many of my students, and on occasion, some of the folks that I run into at these types of events, they think groundwater is a big, giant underground lake. It is not. The water we're talking about is in between the nooks and crannies of the sand and gravel. So we've got sand and gravel in the subsurface, and we have water that trickles, moves in between that sand and gravel. And this picture does a great job showcasing that. One of the things that I don't like about this picture is that it looks like the sand and gravel is floating in the water. That's not what happens. All right, this picture is a little distorted. When you think sand and gravel, this is the picture you need to have in your mind. All right, deep underground, some places 10 feet, some places 200 feet. It really varies in our area. We've got these layers of sand and gravel, and they happen to hold water, and that's where we all get our well water. Some of you have local shallow wells, others have deeper wells. The well that we're talking about tonight is the deeper one. And then this is the very specific scenario that we happen to have in our area. We got a lot of these beautiful lakes. We have a local groundwater table that's near the surface. You can go down 10, 20, 30 feet. Some people have very shallow wells. We're not talking about that water tonight. Instead, we're talking about this really deep water way underneath. And this is the first time that I've talked outside of Ohio or Indiana. We're finally in Michigan. We're actually right here on this lake right here. And the water we're talking about is way down over here near Pioneer. It travels a long way underground in that sand and gravel. One of the things I don't like about this picture, it makes it look like this is a giant underground lake. All right? It is not a giant underground lake. It is water inside of sand and gravel. And you guys are in a very unique position here in Michigan. You guys are the headwaters. You guys are the source for all of this water. We're talking about withdrawing it down here at the bottom of the hill. And one of the very easy lessons you can learn tonight, water flows downhill. It starts up here with you. It ends up down near Pioneer. It happens all underground. You can't see it. Happens over a time frame you can't possibly imagine. And we'll hit that a little later. And then because that last slide makes it look like it's a giant underground lake, we're going to follow it with this one. And we want you to think about this layer of sand and gravel deep underground. Some of that sand and gravel peeks its head out here in Michigan, and that's where some of the recharge comes from. That water travels very slowly, and it ends up coming out near Archbold and some of the other towns in Ohio. All right, it's a long trip, takes a long time, and then along the way, many of us use it as a groundwater resource. There's a problem with this slide, though, too. Here, it makes it look like we know exactly where this sand and gravel is. It looks like it's a nice, consistent layer that we can find underground whenever we want. It is not a nice, consistent layer that happens to be wherever we want. In our area, this sand and gravel jumps around. Sometimes it's 50 feet, sometimes it's 200 feet. It jumps all over the place, and if you have adjacent properties, it can move 20, 25, 30 feet. Ask some of the wells drillers around here. It's interesting where you happen to find the layers of sand and gravel. And then in our area, we happen to have a very unique situation. We have sand and gravel. This is what holds the water. It's sandwiched between two layers of clay, and this clay helps protect it. Clay doesn't let water travel very well, and it protects it from contamination, a variety of other things. So we have a very clean water source in addition to a quite prevalent water source. And then the lens, the layer, the thickness of our sand and gravel, it also varies quite a bit. On the low end, 20 feet. On the high end, 120 feet. The more sand and gravel you have, the more water you can pull out with your well. So clearly, if you want a high capacity pump, you want a deeper 120-foot thick aquifer. Now, I've spoken quite a bit in Ohio. Many of my slides today focus on Williams County, and that's because that's where I have the most information. There was a really good study done in the 80s on Williams County, and that's why I'm going to use their information most often. I do have a few Michigan things sprinkled in for you today, but all of the information, I have to say, applies across the aquifer. But in Williams County, the best wells happen to sit above bedrock. These are down near Bryan, and these are some really high capacity wells, and they can pull out quite a bit of water. So we do have some really good wells in the area. We have some that are slow and consistent. Generally speaking, we have a very good water source. Our water source is so good that in Ohio, these are all of the people that have wells of some type. All right, they aren't all in the deep aquifer. Some of these things are in shallow aquifers. Some of these wells are no longer pumping, but this is the Ohio record that you can pull off of the web. Here we've got Williams County, Fulton County, and Defiance. And then one thing that I want you to keep in the back of your mind today is the number 10. And collectively, this is what Williams County, Fulton County, and Defiance County currently pull out of the ground all together. Williams County, all of the wells you see here, pull out about 6 million gallons a day. Fulton County, 2 million. Defiance, another 2 million. Add that up, you get our magic number at 10. And we want you to keep thinking about that for a little while. In Michigan, it's a little harder to find data, but if you get lucky and you press the right buttons, you can find the well logs here for Hillsdale County. These are all of the registered wells in Hillsdale County. Again, most of these are in the deeper aquifer, but not all of them. And then some of these aren't in what we call the Michindoh. Some of these on the upper northwest part might be in a different aquifer. I did not have the time to take a look at where the cutoff was. I apologize for that. So not all of these wells are in the Michindoh, but these are all of the people using groundwater in the area. It is a valuable resource. And as a county, you guys actually pull out more groundwater than the neighbors. You got a few farmers that have some high capacity operations, but you guys are pulling out 13 million gallons of water. Really close to that number 10 that we want you to think about. The whole county, every single well, every business, every county, every city, everybody together is pulling out 13 million gallons. All right, so this is the slide that you clearly don't need to remind it of. This is why you were all here. Hopefully you all appreciate that this aquifer we have is a spectacular resource for us. This first map, the red line is from the sole source aquifer. The little gray line I've added from the maps in Indiana. I don't exactly know if this cutoff here is accurate, but my guess is it's pretty close. The water above this actually flows north and west towards Lake Michigan. So we don't consider it to be part of our aquifer because it's flowing the other direction. But we've got 9 counties here, and we all rely on it extensively for our drinking water. Now, hypothetically, I'm an engineer. I have to make some assumptions today. I don't know if this 10 million gallon per day project is going to come to fruition, but it's certainly talked about quite a bit. So, for the next hour, we're going to talk about a 10 million gallon per day project. I'm going to use 10 because it's the number I see in the press most often. I have no idea if this is 10 million gallons, 14 million gallons, 20 million gallons, or even 120 million gallons, as has been mentioned in 1 or 2 video conference calls. I'm going to shoot for 10. Nice round number. It's still going to be something that might aggravate you. All right, I want to put everything into context just a little bit. I personally think a 10 million gallon per day project, on top of all of the other well uses in our area, is a big deal. All right, 10 million gallons on top of everybody else's 75. I think that's a pretty significant increase. But if you're shopping at Kohl's and you talk about a 15% coupon, are you really impressed with a 15% coupon from Kohl's? Not so much. So there are people that might argue that 10 million gallons on top of 75 is not a big deal. I certainly think it is a big deal, and I have another slide in a few minutes that'll hammer this point home even more. A little more context. Each glass of water up here represents 1 million gallons per day. At the bottom, we've got our hypothetical 10 million gallon per day project. And then we have all of the other counties. A 10 million gallon single withdrawal for one single project is more than any county except Hillsdale. It is the only county that pulls out a little more. All right, think about that. All of the people in the 9 counties, and we've got one project here that's going to dwarf essentially every county single-handedly. All right, switch gears a little bit. Put on my engineering hat for a bit, see if I can guess where some wells are going to go in. There is quite a bit of data out there. This is from the Fulton County Water Supply and Demand Analysis. Some of the other data I have is from Williams County. But we've got maps that show where we have good quality wells and where we can get good flow rates. So if I were looking for a place in Fulton County to put in a well, I would certainly pick somewhere in the orange or green, or orange or blue, which has the highest flow rates. And that's exactly what we know is happening. All right, we've got a location in Fayette that's been in the news quite a bit. There's a meeting that's going to happen in Fayette here in a bit. I've got the details if you haven't seen that already. And this is the one that you've seen in the news most recently, and it's the one that I'm going to hit and focus on a little bit today. But I don't want to forget about a second location that I've talked about in all of my talks over the last few months. And this is a property that Artesian of Pioneer has access to. They own this property just off the interstate. So while all of the newspaper and all of the press has been hitting the Fayette, because that's where the EPA permits are associated with, I don't want you to forget this one here off the interstate, because Artesian of Pioneer owns this property as well. All right, if you have seen me talk at all in the past, we're finally getting to some new information for you. These are the wells that were sampled sometime in November or December. I don't have any exact dates. None of that information has been published. We do have the well logs. So all of my information here comes from the Ohio DNR. They publish all the well logs. All the well logs are available online. You can go look at them, see where their water is, see what the aquifer material is. And there's a farm here, and this was the well that was tested. They drilled 3 new wells, the orange/yellow. Those were the 3 wells that they drilled, and they used them as essentially observation wells to see what happened when they turned their big pump on. Again, I don't have the data. I will never get the data. I'm sure they're going to keep that to themselves. The thing that I really want you to think about here, look at how close we are to the city of Fayette's wells. Very, very, very close. Now, I don't have the data. I have no idea what it says, but I can make a good guess when I look at the data I can get access to. These are the depths where they found water in all of their wells. So here in their test well, 77, 87 feet. Observation wells in the same area. But this observation well here to the south, they found water at 2 locations, 70 feet and 200 feet. And this 200 feet matches where the wells are for the city of Fayette. And after they got this data, Artesian of Pioneer has changed their mind. They're no longer looking at this as a production well. They have shifted their focus, and this is the location where they want to put in the production well. All right, so when you hear in the newspaper, there's an EPA permit for a production well. They're talking about this site right here. If you go to the Ohio DNR, you can find the address, you can find all the data you want. It is all public information. A little context. This well is 1.6 miles from the Michigan border. A little longer if you go in the direction of the groundwater flow. We'll get to that in a bit. And it's less than a mile from the Fayette production wells. If I were the city of Fayette, I would be slightly worried. This well is very, very close. And if you look at the EPA documents that Ohio has sent and you have access to, they actually have overlapping circles showing that these wells probably do talk to each other. These wells probably do interact with each other, and that could certainly be a problem for the city of Fayette. Again, none of this testing has been done. This is what they're talking about doing with this permit, and we need you to ask good questions if you happen to go to that meeting next month. The permit that the Ohio EPA has tentatively approved is for a 1.7 million gallon per day well. I like million gallon per day units. It's the way that I think. Some of you here like gallons per minute. This is 1,200 gallons per minute. Whichever large number makes sense to you. This is what they hope to get out of this single well. They're going to try to get a permit. They're going to try to test it. They're going to try to bring it online as a production well. Does 1.7 sound like it's very close at all to 10 million gallons? Not even close, right? So they've got 1.7 million gallon per day well. We're not even close to 10 million gallons. So how do we get to 10 million gallons? We have to add a few more wells. As soon as you add a few wells, we call this a well field. And my guess, all right, my assumptions, some of the calculations I can do with the information I have, my guess is that they can make well fields in our area that can pull out 4 million gallons per day. This is my guess. I've got a few good numbers to back it up, but I really need some good data to verify this. They've got one production well that they've put in a permit for. It means they need a few more permits for a few more production wells, even to get up to 4 million gallons per day. So this one well that the EPA is talking about, it is a first well. They need at least 3 to get to 4 million gallons per day. To get to 10, who knows how many wells they're going to need. All right, so this is a long, slow process. They're starting with one well. They're going to need 15 or so to get up to their 10 million gallon per day mark. And it'll be interesting to see where those wells go as this thing progresses. All right, if you haven't already seen this information in the newspaper, don't worry about writing it down now. It's on the slides. You can access it afterwards. If you have nothing else to do on March 12th, I imagine they're going to have some overflow parking at the Fayette Local School. If you can't make it on March 12th, we urge you to write letters discussing whatever you would like to discuss. The Ohio EPA is accepting letters. As residents of Michigan, Indiana, Ohio, anybody that might be affected, I'm sure they're going to take into advisement. All right, try to say good, nice things. All right, do your best to come up with 1 or 2 points that you can help sell. And my job tonight is to give you a point or 2 that you can sell in your letter. If you can't make it March 12th, send a letter. All right. That is the Fayette site. But I've spent too much time thinking about this site here on the Tiffin River that I can't push it out of my presentation just yet, because I'm afraid that it's going to come around on the next round of permits, and this is what we're going to be targeting next. There's a 55-acre site adjacent to the Tiffin River that Artesian Pioneer has access to, and I want to make sure that you certainly don't forget it. For a little context, I'm from Indiana. I've been there 9 years, but honestly, I really am still from Iowa, so I need a good picture to let me know where everything is. We've got Harrison Lake State Park, we've got Pioneer, we've got Hillsdale, Archibald, West Unity. There really isn't anything around this site except for farms, which is one selling point. If you're going to put in a well field here or a water treatment plant, there's nothing else to disturb, and that's why it's a pretty good spot for a wastewater treatment plant or a well field. Again, I'm making a wild guess here. I have no idea. This is a giant assumption, but it's an assumption that nobody's told me I shouldn't use just yet. Under this property, there is currently 860 million gallons of water. All right, this is slightly misleading. All right, I'm going to do something I probably shouldn't do. I'm going to lead you down a path. I'm going to make you think about something that's not actually accurate, but I want you to do it anyways. 860 million gallons divided by 10 million gallons per day. How many days before the water underneath this property is no longer underneath that property? All right, so we can all do 86. Now, that's not exactly how this works. All right, we do have this nice little layer of sand and gravel. It does have a little water in it. And yes, if there wasn't water rushing in immediately after we turned on the pump, we would dry this out in 86 days. But that's not how groundwater works. We don't have to worry about that happening. I can't imagine it would dry out in 10 or 100 years. But it is something I at least want you to think about for a moment. All right, so the hard science. You're actually learning way more than you thought you would learn tonight. I apologize. We got to do it. How does the water actually work in this aquifer? The Michindoh is a confined aquifer, a little more difficult to think about than an unconfined aquifer. A A confined aquifer simply means that we've got a layer of clay over top of our water. So our sand and gravel is lower. We've got clay above. And because we have that clay above, it puts our water under pressure. So when you drill a well and you tap the aquifer, you don't actually see the water at the level it is in the ground. Because it's under pressure, the water will actually rise in your well. In some places, it rises above the ground level, and that's an artesian well. And I imagine some of you around here have seen artesian wells, especially if you spend any time in Fulton County. Apparently, they were quite prolific 20, 30, 40 years ago. All right, we've got water. When we put in a well, it comes up to a level that shows the pressure. Now, before we turn the pump on, if we put in wells all around the aquifer and we looked at where the pressure was, we would have this level of pressure. And the big scientific word today is potentiometric. Don't ever say it again, that's fine. It's a fancy word that says this is the pressure that the water gets pushed to. The water's actually down here in the sand and gravel. But when you put in a well, because it's under pressure, it rises in the well to this potentiometric surface. Now, when the wells are not turned on, we got a nice flat level. Some of these have rises 50, 60, 70 feet. Some places the water actually spills out. As soon as you turn the pump on, we get drawdown. That pressure surface changes. And the thing we really care about here is the radius of influence. And the radius of influence tells us how far this well reaches to get its water. All right, are we reaching half a mile? Are we reaching 2 miles to get our water? And the reason we want to know this, we want to know if we're impacting other wells in the area. We want to know if we're impacting lakes or rivers or creeks. And our radius of influence can help us figure out, are we going to adversely impact others in the area? And with our well testing, we can figure out these values quite readily. Again, I don't have access to any of the well data, and I imagine I will never have access to any of the well data. Fortunately, there's a gentleman named Cohen, and in the 80s, he did a spectacular study. If you care about water at all and you can read any scientific papers, this is a decent read. He did a great job studying Williams County. And he essentially looked at radius of influence for hypothetical large wells. This is 1980, and he thought an extremely large well would be 5 million gallons per day, or 6 million gallons per day. He had no idea that 10 million gallons or 20 million gallons might be coming our way. But he did push the envelope, and he did think about 5 million gallons per day. And if you look at this well down here in the corner, this is the radius of influence for 5 million gallons around on the surrounding community. And it's about 4 or 5 miles. It really stretches in some parts of the aquifer. Now, there's no data up here in the area that we're talking about, but with some pretty easy math and a calculation or two that my students do on a few of their tests, we can make some good estimations for how big a radius of influence might be for the wells that we're talking about. So here's Fayette, and this is essentially the radius of influence for a 4 million gallon per day well field. Not that 1.7 that the permit is for, but a larger well field of 4 million gallons. Still not 10, but I think they can pull 4 million gallons from any single location. And our drawdown is pretty significant for a reach of 1.25 miles. It's a sizable radius of influence. Because we've got sand and gravel, the aquifer recovers pretty well. In other parts of the country, this radius of influence would be much, much bigger, and it might be more of a concern. Here's the radius of influence for that Tiffin River site. Now we got 4 plus 4. We're up to 8 million gallons. We're still not at 10 million gallons. So where are those other well fields going to go in? I have no idea. I wish I knew what the plan was so that I could start giving appropriate talks that could project where the next battle might be. Here I've got 5 4 million gallon per day well fields. The reason I've got 5 is that if you're going to produce 10 million gallons per day, you have to be able to pump 20 million gallons per day. EPA says if you're permitted for 10, you're going to produce 10, you have to be able to produce 20, and that's why I've got 5 4 million gallon per day well fields here. All right, if you want to produce 10 million gallons per day, this is what our future might look like. Again, I have no idea. I'm just making some good guesses here, but they're as educated a guess as I can possibly make. All right, next I want to switch gears just a little bit. You are going to hear some interesting things over the next couple of months if you haven't heard them already. I really want to try to give you reasonable information. There are some interesting things that are being said, and I want to make sure that you can have a good conversation with your neighbors, the folks at church. I really want you to have a reasonable discussion, and that's what the next few slides addresses. So first, you are going to hear quite a bit that there is a lot of water in the Michindoh. And this is absolutely true. We got a lot of good water. But for this project and projects like it, it does not matter. All right? Yes, there's a ton of water, but it just doesn't matter. And the reason that it doesn't matter is that groundwater moves very, very slowly. The water here underneath us tonight might take 70 years to reach Fayette. So even though you guys have good, plentiful water beneath you, it's never going to get to Fayette in your lifetime. It's not going to get to Fayette in my lifetime. My little one's 5 years old and might get to Fayette in her lifetime. All right, the time frame for travel for groundwater is decades, hundreds of years, thousands of years. And that is simply something that most of us can't think about. And to understand this, we want to talk about groundwater flow. Again, I'm going back to that Cohen report. In our area, the groundwater flows from northwest to southeast, from Hillsdale almost straight to Fayette. It's off by a mile or two, but it's pretty close. All right, so eventually the water we're sitting on tonight will get to Fayette. I live here in Angola. Our water heads over towards Bryan. And we've got some really good data. We know exactly how fast this water moves. I've been preaching 0.5 to 2 feet per day for the last 4 months. And going through some of the Artesian and Pioneer articles this week, some of the things that are attached to the Ohio EPA documents, I felt really good when they said that their groundwater velocity in Fayette is 1.2 feet per day. All right, so I have matched their number exactly, 0.5, 2, they say 1.2. I actually felt pretty good this week when I read that report. So I am glad that I'm accurate with my groundwater velocity calculations. Now, what is 0.5 feet per day? It is a speed that you can't possibly think about. Common snail, 3,800 feet per day. Do you know how slow a snail is? It is just something we just can't think about. And our groundwater is moving much, 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 much slower than that snail. All right, water moves very, very slowly underground, and that's why it's not available all across the aquifer instantly. If you turn a big pump on, a giant pump, you can increase the speed of the groundwater. My guess here is maybe 6 feet per day near the well. So we are going to speed things up a little bit, but it still means that water is moving very, very slowly. 6 feet per day is still a whole lot less than 3,800. And what does this mean realistically? So here is how the groundwater would flow from the Michigan border to that production well in Fayette. It's not quite a 45 degree, but it's pretty close. It's about 2.25 miles. And at the 1.2 feet per day, it's going to take 27 years for that water to go 3 miles. All right, you cannot possibly imagine how slow this water is going. If we turn on a big giant well field, maybe we get up to 6 feet per day. Then maybe it takes 5 years for that water to get to the border. Now, most of you here are concerned, and I think you should be concerned. And I will tell you why I think you should be concerned in a bit. But the water under your feet right now is not going to reach Fayette, Ohio anytime soon. All right, so I got a 5-year-old. In her lifetime, it's going to reach there. And there are some other reasons why this project is certainly an issue. But if you're worried about stealing groundwater immediately, it's just not going to happen. All right, the water moves much too slowly. It is not going to be stolen out from underneath your feet anytime soon. Now, over generations, potentially, but we're talking about very, very, very slow velocities. And for that reason, I want you to stress the water all across the aquifer is not available for this project. Yes, there's a lot of water. There's a ton of water. Across the aquifer, we could handle 10 million gallons per day. The problem here is they want to pull 10 million gallons per day from a very specific location. And not all of the water across the aquifer is available instantly. It's available in 25 years, but that's certainly not the time frame that they're talking about. All right, I tend to talk a little too much. So in my classes, I try to interject questions to stop myself. You guys have been listening for a while now. You know groundwater is slow. There are 4 counties that are likely going to contribute water to this project in the next 25, 50 years. Has everybody figured out what 4 counties that happens to be? We got Fulton, Williams, Hillsdale, and I don't know if I can pronounce this correctly, but is it Lanawi? Thank you. All right. Angola, this project's not going to affect us for 200 years. And the folks in my town don't like it when I say that. Auburn, Indiana, it's not going to affect them ever because they're actually below this. But the counties that you all represent are likely going to contribute water. And I'd like to revisit that pie chart from earlier. Collectively, Fulton, Williams, Hillsdale, you all pump out 30 million gallons per day. We're going to add 10 million gallons per day on top of that. Now, 10 million gallons per day looks like a gigantic chunk. All right, remember, the water is not available across the aquifer. It's only available in the local area. And when you say 10 million gallons per day across these 4 counties, it is a much, much bigger project. You're going to hear over the next couple of months from a variety of people that groundwater is a renewable resource. And it absolutely can be if it's managed properly. And I hate to say it, but we've essentially gotten lucky here in the tri-state area over the last 200 years. We have small communities. We have farms that are responsible. We have businesses and industry that are responsible. We have the right size populations for the water beneath our feet. And accidentally, we have done a good job managing our water. However, moving forward, if we plop 10 million gallon per day projects throughout the aquifer, that might not be the case. And it hasn't been the case across the rest of the country. I grew up in Iowa, right here on the Mississippi. My house was in the middle of a town, and I still had 3 cornfields on each side. We pumped out a ton of water to irrigate more crops than you can possibly imagine. My wife is from Kansas. They have pumped out more water to irrigate crops than you can possibly imagine. We have collectively, in the U.S., dropped water tables for a variety of applications at rates that are astounding. We have drained aquifers across the country. And to think that we can't drain ours is rather absurd. Compared to the Ogallala Aquifer, our little Michindoh, which is like just barely my green dot here, right? Just barely my green dot. This is the Ogallala. It's been drained. It is 1,000 times larger than our little aquifer. If it can be drained, ours certainly can be drained. And then here's a blow-up of the Ogallala. If you're interested, if you Google search Ogallala, you'll find more information than you can possibly imagine. The thing I want to showcase here is the localized effects. Right? The droppage isn't across the entire aquifer. It's only in the places where the most water was withdrawn. All right? Localized effects. The water isn't available across the entire aquifer. All right, so when I go to the meeting March 12th, and if I'm allowed to ask a question, this is the question that I'm going to ask. How is the Ohio EPA going to ensure that our water withdrawals are less than what the aquifer can yield? And at this point, the Ohio DNR, the Ohio EPA, essentially doesn't have the information to make this assessment. We just don't have the information. We would like to have a few more studies, but there just isn't money to do those studies. But if I'm allowed to ask a question, this is going to be my question. What are we going to do to make sure that our withdrawal, how much we pump out, is less than what the actual aquifer can provide? Because at this point, we just don't know. All right, you're also going to hear over the next couple of days, or months, or years, or however long this is going to go on. There's plenty of recharge in our area. The Michindoh, it's got water. It gets fresh water. It gets clean water. It gets returned. It gets replenished. Again, this is a true statement. We have good recharge. And the people that have the best recharge are you. Hillsdale County has the best recharge rates. 13, 14, 15 inches per year. It's amazing how much water you guys get penetrating your soils. You guys have the best recharge in the entire aquifer. And that's why in our little map here, we've got you isolated as the recharge zone. You guys are closest to this aquifer. You've got the best soil conditions. Down here where we're pulling the water out, not so much. And again, my question, is the water under your feet available to Fayette? No. So it doesn't matter that you guys have good recharge. You have good recharge, but the wells aren't going in here, we hope. The wells are going in somewhere else. So it doesn't matter that you have good recharge. It matters where the recharge is in the Fayette area or in the Tiffin River area. Rainfall does contribute, and we do have some reasonable estimations for how rainfall contributes to recharge. And this happens because the clay sitting on top of our sand and gravel is a little leaky. So when it rains, there are holes and other ways that the water can trickle through our clay. It happens very, very slowly. But we can get water that goes through and eventually ends up in our aquifer. And we have reasonable estimates. This is rainfall. We get 35 inches per year. Of that 35 inches, 8 to 10 gets into the ground up near my hometown. There are parts of the aquifer that essentially get zero recharge. The clay layer on top is so tight, it is so good, it doesn't let any water trickle through. Other parts, it's a little leaky, and it lets some water through. And I apologize, I don't have good data for Fayette. The closest thing is Bean Creek. I don't actually know where that is. I apologize, I didn't look that up to see how far it was from Fayette. They do get 8 inches per year. Yeah, it's part of the Tiffin River. I just don't know how far from Fayette. But even 8 inches per year, this is not the 35 inches of rainfall that you're getting. All right, all of the rainfall doesn't go into the groundwater, only a small portion. And then this was done in 1980 something. Have we changed the way that we tile our fields since 1980? All right, so all of this is pre-heavy field tillage. I imagine the numbers are slightly different now. We don't have good estimates after we've changed some of that drain tillage in our fields. So this might be the high end for how much water we can get back in, which means we might not have much. I don't know why I still have this in here. You might hear over the next few months or years that unpumped recharge is surplus water. Now, I've said a lot of things tonight. This one is simply patently false. All right, everything else has been true, but it doesn't really matter. This one, just not true. Unpumped recharge is what nature has been using for thousands of years. And we have good data on our groundwater levels. The groundwater is nice and consistent. This is a well over by Pleasant Lake in Indiana on the Ohio side. It hasn't changed in the last 10 years. If unpumped recharge was excess, this water level will be going up and up and up and up. But it doesn't. All right, the levels are nice and consistent. Again, we have gotten lucky. The number of people, the size of our cities, the type of industry, the type of farming we do, we are currently in a good equilibrium. We are in a good relationship with our groundwater. Things are nice and stable currently. So, where does that go? Our creeks and streams get water from two sources. One is surface runoff. When it rains, you see it run into the creek, and you can very easily see surface runoff become stream water. It's the thing you've thought about your entire life. I see rain go into a creek, that is stream water. Now, the stream water that you haven't thought about comes from groundwater. Now, my example here is coming from the shallow aquifer, but our Michindoh likely contributes to streams in certain parts, and this is called base flow. So our groundwater feeds our streams in certain parts of the aquifer. In some parts, the aquifer feeds the streams. In other parts, the streams feed the aquifer, and it really depends on where you happen to be. But all of that excess water, it's not just extra. Nature has been using it for quite some time. And again, this happens because our clay, our overlayer, it's a little leaky. So in some places, it can trickle down and become part of the groundwater. In other places, it can actually become a stream. And again, that might take another hour to explain, but if you want to know, let me know afterwards. And in our area, groundwater is a significant part of our streams and creeks. 25% on the low end, 40% on the high end. Again, not all of this is Michindoh water. Some of it is that local surface water. But we've got some good water resources in the area, and our groundwater feeds it quite a bit. I teach the sustainability class at Trine. I try to hammer home sustainability whenever I can. We really want to keep the natural cycle in its place. We really want to keep that water following its natural path. We don't want to just send 10 million gallons straight to Toledo. But this argument has been made by several people. We really want that water to follow down towards Fort Wayne, make the weirdest left turn I've ever seen, and then head back towards Toledo. We really want to keep that water in the spot that it's been going for quite some time. And then one of the crazy things about the water in our area, the surface water generally goes southwest. The groundwater generally goes southeast. So just because you see the river flowing in one direction, our groundwater happens to be going in a different direction. All right, my wife is also an environmental engineer. So here we're going to move on to a few doomsday scenarios. I apologize that they are doomsday. For the next little bit, imagine we got a 10 million gallon per day project, maybe a 20 million gallon per day pumping rates at certain times of the year. It's already in place. What are some potential hazards associated with such a large pumping operation? If the well fields are in the wrong spot, we could cause streams to dry out. All right? One of the locations is right on the Tiffin River. Again, it's not directly connected, but it might contribute to some creek loss. And then look at the flow rate here. We are right at that 10 to 20 million gallons per day level again. All right, I don't know why this number keeps coming up, but it's 10 to 20 all over the place. Again, I've talked in Ohio most, so Harrison Lake State Park is the one I know is fed by groundwater. I imagine you have some lakes around here that are fed by groundwater. If there was a large pumping operation near your lakes, you could see some decline. But you got to be right on top of the lake. Remember, our radius of influence is only a mile or 2 miles. In order to see effects, you got to be right on top of the pumping station. We're going to lower the water table. We're going to lower the pressure. And any remaining artesian wells that are out there are likely going to stop flowing. Talking with a few engineers last month, it sounds like many of the artesian wells that used to be in Fulton County have run dry over the last 10 or 20 years anyways. Any of the ones that are left would likely start to run dry. We're going to lower the water table, and it's simply not going to flow. And then I know I have a few drillers in the audience. They're not going to like the next few slides, but I'm going to scare the bejesus out of you anyways. Our confined aquifers, they are under pressure. They've got this clay on top. They've got all this water pressure that's causing the water to rise in the well. That means our sand, our gravel, everything is under pressure. This pressure actually supports the clay layer on top. Right? The water underneath is under pressure. This sand and gravel in the water, it's actually supporting, it's the foundation for the clay on top. So what happens when you start to change that pressure? You start to depressurize, you start to make some big changes. Large withdrawals could have some localized issues, and you could see changes in the landscape. I have no idea how big these could be. All right, it might be an inch. It might be 5 feet in areas close to the well. And again, this has happened elsewhere in the United States. In California, they dropped the land surface 9 meters, 27 feet. All right, our aquifer is not this big. We couldn't possibly drop it that much. And they are doing some really intense farming. Remember, California is providing all the wine in the U.S., and they're providing all of your fresh fruits and vegetables all year round. So they're doing really intensive farming. All right, they're pulling out more water than you can possibly imagine. All right, and our aquifer is not that thick. It's not under as much pressure, but it certainly is something that needs to be thought about. In the area around these wells, are we going to have any problems with land changing? I have no idea. And the well drillers here probably are much better to address this question than I ever could be. But it's something to think about. As the wastewater treatment plant designer, I got to make sure I throw in this slide. We've been talking about wells for quite some time. Most of the things you see in the news are about wells. Toledo is where this water is heading. They currently have nice, soft water. Your water at home, is it nice and soft? Yeah, I didn't think so. So, we can't forget about treatment. At some point, there's going to be a treatment plant. It has not been discussed at any point in any permits, so I don't have any idea what it's going to look like. Again, I'm making a guess here. My guess is that they're going to use nanofiltration or ion exchange. It's a guess. I don't know. But with this type of waste comes really salty, briny solutions. For your water softener at home, how do you recharge it? How do you replenish it? you use salt water. It goes down your drain. Imagine that for 10 million gallons per day. The waste stream is usually on the order of 10%. So, if we've got 10 million gallons per day of water being treated, we're producing a brine waste that's 1 million gallons per day. And where are we going to put this? The reason I've left the Tiffin River site in the presentation is that my guess is that a treatment plant is going to go on that site at some point when they get enough well fields. I don't know what a 1 million gallon per day brine does to the Tiffin River at that point, but it's certainly something to think about. And then this is my wife's slide. She's also an environmental engineer. She's actually the professional engineer in the family. Her concern is not this singular project. All right, we both understand groundwater flow well. We know that water in Angola is never going to end up in Fayette. We know that water in Hillsdale is going to take forever to get to Fayette. But our concern is that this is the first project. What does the second project look like, or the third project, or the fourth project? And once one of these goes in, what's going to stop the next project? Once this project goes in Ohio, what's going to stop them from pumping your part here in Michigan? So our concern is that this is, I don't want to say gateway drug, but this is a gateway drug. What happens when we have one successful 10 million gallon per day project? Are more coming along the way? It looks like it could be cheap, easy money. Pump out water, a little treatment, and you can sell it to the highest bidder. And we've got quite a few large cities in the area. So this is our personal issue, right? I'm okay with most everything else that I showed you, except the last slide with the treatment. I can make arguments on both sides for a lot of things. But my concern is that we're going to see many, many more projects like this, and I'm worried we're going to have one in Steuben County. All right, it's 8, but I'm going to go on for 5 more minutes. I want to give you good arguments for conversations with your friends, your family, any people that you have in the Toledo area that you would love to argue with. So I'm going to shift my focus just a little bit. And I want to remind you that the folks in the Toledo suburbs, they got plenty of water. They got plenty of water. This is a Google map. I see a nice river running right through the middle of town. Maumee River runs right through the middle of town. We got great data. Low flow, 175 million gallons per day. I can very easily put a 10 million gallon per day or 5 million gallons per day water treatment plant right there on the river. No problems. They got plenty of water in some of these suburbs. Better yet, some of the suburbs actually have groundwater beneath their feet. It's not as good as ours. It's not as close to the surface as ours. But underneath the airports and a few of the other suburbs, there is good groundwater. It's a little harder, it's a little deeper, but it's right there underneath their feet. And there's some good reading. Again, if you like really old reports that predate me, there's some good information out there about the groundwater in the Toledo area. So, yes, we got great water. We would love to share with the people in this room and the people in the surrounding counties. I don't know that I really want to share it with the folks at Toledo. They've got their own water, and I want to make sure that you're aware of that when you're having good conversations with your friends. All right, we're going to leave you here with a few items that I want you to chase down or think about. I've given you a ton of information tonight, and I don't know where this is going to go over the next few months. When I first talked at the Steuben County Library in last November, I never thought I would be on talk number 5 in the 5th county. I'm really glad that you all are interested. I love that I get the 55 and over crowd. Is there any way we can get the 25 and over crowd? So think about how we can get the 25 and out of a crowd. I would love to see a few young people. The other thing I want you to think about, can you have good conversations with folks about sustainable development? Think to yourself, if I had 10 million gallons per day that I wanted to dole out, who would I give it to? Would that be two large industries that employ 1,000 people? Or is it one water treatment plant that employs 10 or 12 people? All right, so think about what you would love to see done with those water resources if you could control where that water went. There's a lot of good information out there. These are the letters that have been sent to and from the Ohio EPA. These are all active links. Take a read. Some of it's slightly confusing. I didn't know what was going on the first time I read it. One of these tells me that I have good estimates on my groundwater, so I really like to hear that. But if you want to know how the Ohio EPA currently thinks, these are the documents that you should look at. Again, the entire presentation, if you're going to write down one thing tonight, this is the link that you should probably write down. Everything is there. All of my sources, all of my links. All right, at this point, I would love to take a few questions. Before we get to questions, if you got to go, if you got places to be, do not hesitate to get up. We don't mind.
Why? What is the main reason that people want water when they get
The question is, why does the Toledo suburbs want our water? I don't know that they do. Normally, when cities are looking for new water supplies, they look around, they hire a few consultants, and they find good local water supplies. In this case, I think someone went to them and said, I can bring you water. So I don't know that it's so much that Toledo suburbs are looking at our water. I think somebody offered the water, but I don't know for sure. And the politics on this are rather interesting.
Hi, Rick Coleman of the we had this problem in Michigan.
All right, so the question is, in Flint, we went from one water supply to another. We pushed it through the same pipes, and it caused problems because the water was different. So there were many mistakes made in Flint, multiple levels. Many engineers should have lost their jobs and or their licenses. Hopefully that won't happen again. The other issue that we have, or the other thing that saves us here, is that your hard water actually protects the pipes. So it's the opposite, right? The reaction that happened in Flint, this would be the opposite. So you pumping your water to their pipes would actually protect their pipes for the long term. It's actually the opposite chemistry. So that is not a concern, but it is certainly something to raise to the Ohio EPA if you get a chance. So Sherry and Lou from the Williams County Alliance, I've not had this conversation with them recently. The question is, can we apply for a sole source permit once again? So the last time that the sole source permit went through, it was going along great, and then there were a few stumbling blocks, and there were a few political issues. There were a few groups that were against it, and it stopped it dead in its tracks. I don't know that the politics are any different. So it would be great if we could apply for sole source. The argument's going to be we don't have enough data. That was the argument the last time, and nothing has changed since that last proposal went through. But I think it would be great if we could find the money to do that. Excellent. So I was anticipating this question in a different form. I thought it would come in the form of Nestle, but she brought out Cleveland and Toledo. You all know Nestle pulls out about 2 million gallons per day from Michigan. 2 million gallons. And we're talking about 10 here. So Nestle pulls out about 2 million gallons. You guys have some really spectacular aquifers, some sandstone up north. Bottled water is it's a problem, yes. We actually have nurses in our town that degrade municipal water that is perfectly safe. I talk to my students all the time about how your water from the city is the safest thing you can drink, but most of them don't believe me. All right, so we're battling like 30 years of that chlorine taste and Brita filters saying your tap water isn't good. And this is a bigger problem, but in this context, I don't know that they're going to be bottling this water. They see this as a straight sales to the cities. A bottling plant would not be something that's on their radar. I can't imagine that's going to happen. Yes. So this goes back to the previous question about sole source. We have a lot of information. We have a lot of good well data. We just don't have the high capacity pumping data that we necessarily need. And it all comes down to money. And states are cutting back all over the place. And I hate to admit it, but we are the small little corners of our states. Do people come crawling to us all that often? Our mayor was in town the other day, and he made a stop at our famous state park. He ate breakfast, and then he was out of there. Or not our mayor, our governor. All right, he was there for a few hours. They don't show up all that often. So I don't know that this is something that our states are going to take care of for us from a study perspective. I think we need to start looking at private foundations. You need to start looking to your universities, Michigan State, Ohio State, and Purdue. And you got to start asking some of those professors, are you interested in studying a little aquifer? At Trine, we don't do any research. It is not our job. We teach. This is something that Michigan State, Ohio State, and Purdue might address. All right. The estimates on the high end are 75. All of that is all of the water from all of the wells for all of the purposes. So the question is, have we seen any effect on withdrawal? That's a great question. But we have one well here, one well here, one well here. We've done a great job of spreading the wealth, and that helps us hide any issues that we've had. I don't know that anybody's looked. No, we don't. And it's not coming for 10 years. And even then, we need a lot of money. So his comment here is the wells in Bryan have dropped 30 feet. In the southern parts of the aquifer, due to the tillage, it is likely to see droppage. And there is some evidence in the southern part, due to tillage, they have seen some droppage. Up here where you guys are, I don't know. Do you know the company name? If anybody, so he's asking, AbsoPure, and where is it located? I was not aware. I will go investigate. My guess is they are smaller than Nestle. My guess is they are less than 1 million gallons per day. Otherwise, it would show up in your news, and people would be making a big deal. My guess, I don't know, it's less than 1 million gallons per day. Her question is recharge and pumping water inside of our aquifer. If we pumped out this 10 million gallons per day and kept it inside of the aquifer, would we be okay? As long as we did some smart things with it. If we discharged it to the appropriate lakes or creeks, absolutely. If we kept it in the aquifer boundary, we could certainly make this water go a whole lot longer than if we pump 10 million gallons per day outside of the aquifer. Absolutely. So there's like 3 or 4 questions that I do not know. And he asked, how much water do the Toledo suburbs need? And it essentially comes down to which Toledo suburbs are you talking about. Depending on the news report, this is anywhere from 1 town to 10 towns. And you have no idea who or what is going to make that decision. 5 of the suburbs might say, yes, we want to do this. 5 might say, we're going back to Toledo. I have no idea, and my guess is worth absolutely nothing. In the end, none of the suburbs might want this water. In the end, they might all go back to the Toledo water because it's what they're used to. Politically, they make up, and in the end, this may be no problem at all. But the other end is true. If he is successful pulling out 10 million gallons, it might go to 20 very quickly. The question is, how much does a drought affect things? On the slide where I said that our groundwater was staying level, and then even my answer to this gentleman that says, have we seen any decreases? When I look at that plot, I actually see a decrease over 6 years, and then we had 2 really good years in the last year, so it recovered. Droughts do affect our water table a little more than others. Things are a little connected, but we got a lot of water. It'll stay there for a while. It would be extended periods that would be a problem. But with global climate change, we have no idea where things are headed. We could have a 10-year drought, and then things could certainly be a problem, but we have no idea to know. So the question is, why doesn't Toledo increase its capacity? That's not the issue here. Toledo has plenty of water to give to the suburbs. The suburbs don't want to pay, and politically there's an issue. The suburbs are not happy with the city is not happy with the suburbs, and there's some giant political rift in addition to the fees. In the hat? Great question. His question is, why is the Ohio EPA the only ones making decisions here? That's because that's the way the rules are written. And this is why we need you to contact your representatives. We need you to send letters to your governor. We need you to speak up for Michigan and tell them, hey, we're 2.2 miles from this well. We care, and we want you to help us out. They're In order to pull anything off here, you need help on the highest level. You need to get your governor involved. I need to get my governor involved. We had him in the city last week. Susan tried to talk to him, but it didn't happen. All right, yeah, he said no. She tried to talk to him last week, and he said no. This is the way that the laws are written in our states. Out west, their laws are written a little differently. It's first to tap, first right. Here, it's essentially free game, currently. This issue essentially hasn't come up yet in the history of the state of Ohio, or Indiana, or Michigan. This issue essentially hasn't come up before. If you would like to protect the natural resource, yes, we got to find some ways to write some things into some state legislation, yes.